For number 1, we are going to plug in our ordered pairs to figure out which one works in both equations. So first of all, I'm going to say x and y, and I'm going to start plugging in. So the 0 seems a little bit easier to work with, so I'm going to start with this one first. So I've got 3 times negative 2, and then minus 0 equals 2. So that would be negative 6 minus 0 equals 2. Well, is that true? No, because negative 6 cannot equal 2. So that cannot be my answer. So B has to be my answer, but I need to make sure I plug it into both equations to make sure it works. So I'm going to have 3 times negative 2, okay, minus a negative 8. That's going to be a plus 8 then, equals 2. So I would get negative 6 plus 8 equals 2. 8 minus 6 is 2. We can see that 2 equals 2, so that's true. So for the second equation, we'll have negative 7 times negative 2 plus negative 8 equals 6. So we're going to say, okay, negative times negative is positive 14. This is really like a minus 8 equals 6. Well, 14 minus 8 does equal 6, so that's true. So since negative 2, negative 8 worked in both equations, we're going to say that is our solution to our system. And number 2, just want to know, where do the 2 lines intersect at? Right here at this point. So this point would be 1, 3. Okay. In number 3, we could do the same thing we did in number 1. We also could use substitution method since we already have y by itself. I'm going to go ahead and just take these 2 points, and I'm going to plug them in to see which one works. So this one, x is 2, y is 4. Well, 2 plus 4 does equal 6, so that's true. Down here, we're going to take y is negative 3. Sorry. Y is 4. Still on the first equation, or first point. And then 4 times 2, minus 4. So 4 times 2 is 8. Bring down our minus 4. 8 minus 4 is 4, so that's true. So since 2, 4 worked in both equations, we're just going to go with 2, 4. Okay. Then in number 4, I would use a marker or a different colored pen or a highlighter, and I would highlight your y-axis and your x-axis. So here's my y-axis, here's my x-axis. Okay. Now, to work with this dash line right here, it's going through the center, which is 0, 0. Okay. So I know that I'm starting at 0. Okay. Now, if I look along this line, I got to find where this line meets another point here. So right here is a good point to use for slope. So I'm going to go up 2 over 1. Okay. So really that's just like 2x plus 0. And then I have a dashed line, which means I have no equal to part. So like right here, there's an equal to part. The little line, we're not going to have that for this equation, or for this inequality. And then in order for the darker part to be shaded, that means I had to shade below that dashed line, which is less than. So if I look to see, we have a match. Y is less than 2x, but they put plus 1 here. So that wouldn't work because we weren't at the 1, we were at the 0. So down here we have one that matches, so that's good. For the second line, we see, okay, this solid line meets right here at negative 7. Okay. Now we need to find another point that we could use. Let's say we could use this point here. So from here to here, I'm going to go down 3, right 2. So negative 3 over 2 is my slope. Okay, and then it's a solid line. So if it's a solid line, it has to have the equal to part. And if we look, the shaded part is on this side. The darker part is on this side of the line. So that means it had to be shaded down right here. And so that would be less than. So we'd have less than or equal to negative 3/2 x minus 7. So this is a match, and so is this. But I'm going to go with the answer B because I have both of those inequalities matching my lines. Okay. Then number 5, we're just going to figure out what type of solution each one of these are. So this is a no solution because the lines are parallel, they're not touching. This is a 1 solution because they meet at 1 point. And then C, this is many solutions. So you have to think that there are 2 lines right here. There's one and there's another one drawn on top of it. So every single point on these 2 lines, they touch each other. So that's many solutions since lines are infinite.